We're getting pretty close here. We only got a few more to go through. For this one, dx dt equals this mess. Whoa, this is a mess because it needs to be f of x times, it looks like, g of t. So in order for me to get that, I need to figure out a way to get this to be in two factors. We're going to pull out a trick that we haven't used in a while. It's called factoring by grouping. I notice that I have a 1 plus t here. And if I factor out a negative x, I'm also going to have a 1 plus t here. Well, then I know that I each have a common factor of 1 plus t. I'll factor that out, 1 plus t. And then left over is going to be 1 minus x. Now I'm ready to start separating my variables. I want the 1 minus x to go over here, and I want the 1 plus t to stay over on the right. So that's going to give me dx over 1 minus x equals, then on the right I'll have 1 plus t times dt. Now if I integrate both sides, here I'm looking at a natural log function, and if my u is equal to 1 minus x, then du is equal to negative 1 dx. That means I'm going to have a negative inside, and I need to balance with a negative outside. Here, this is just a simple, straightforward power rule integration, integrating 1 dt and t dt. So on my left side, I'm going to have negative natural log of u, which is 1 minus x, equals to, on the other side, we're going to have 1, the antiderivative of 1 is just t, and the antiderivative of t is t squared over 2, and of course plus c. Now again, we're trying to get that x by itself because that's what we had in our original numerator. So I'm going to get rid of this negative by multiplying both sides by a negative. That's going to give me positive on the right, and all of this is going to be times a negative. Then I need to take e to both sides. So I'm going to have e to natural log, those undo each other. We'll have 1 minus x equals e to the negative, and then we got t plus t squared over 2 plus c. Now I notice here that if I just move the x over to the left and this whole term over to the right, then I have x by itself. So let's go ahead and do that. That'll give me x on the right, and on the left I'm going to have 1 minus e to the negative t plus t squared over 2 plus c. We are done with this one. So we have x on this side and a function of t on this side. Let's keep moving. Okay, now we have some additional information. We have an initial condition, and when you're given an initial condition, that allows you to solve it a little bit further than you had originally started. So I notice that this is x times e to the negative t. I'm going to take that even further and say that's x over e to the t, because a negative exponent just means move it to a different part of the fraction. And then we have dx dt here. So when I times dx dt, so we have here x over e to the t equals dx over dt equals 1. What I really want is dx's with x's and e to the t and dt over on the other side. So I'm going to take these two pieces here and move them over. Just multiply them by the 1. Then I have x dx equals e to the t dt. If I integrate both sides, that's going to give me x squared over 2 on this side equals e to the t on this side. It has x of 0 equals 1. That implies that this is my t and this is my x value here. So x equals some function of t. That being said, I'm going to put my constant over here with the t and try to work it out. Now again, I need to get this x by itself then. So I need to multiply both sides by 2. That's going to give me x squared equals 2e to the t plus, now 2 times a constant is still just a constant. And then I need to square root that to get rid of this squared. So I have x equals radical 2e to the t plus c. Now this information here though is going to be helpful to me, because if I know that if I plug in t equals 0 and I get x equals 1, I can use that to solve for c here. So x is going to equal 1, t is going to equal 0. I'm going to see how the rest of the relationship unravels. Well, e to the 0 is just 1. So that's 1 equals square root of 2 plus c. If I square both sides, then 1 equals 2 plus c. And c is equal to negative 1. So then that helps me to replace this c with negative 1. So x equals a function of t. And that function is the radical 2 times e to the t minus 1. There's my constant right there. Let's try another one kind of like that. So here we have a lot of things going on, but what you want to realize is just get this y over here and get the dx over on the right. That means I'm going to have dy times y equals, and move the dx over to the right, I'm going to have 1 plus x over x times dx. And when I integrate both sides, this right here can actually be split into 2 integrals, or 2 terms at least, however you want to phrase it. It'd be 1 over x for one of them, and then 1 x over x for the other one. And on the right side we just have y dy. So after I integrate both of those, I'm going to have y squared over 2 on the left. And on the right, I'm going to have natural log of x plus x. And then I'm going to add a c plus a constant over here. Now I'm going to go ahead and use this information right now. Y of 1 equals negative 4. I'm going to put, that means that this is my x and this is my y. When I plug in x is 1, then y is negative 4. So it means negative 4 squared over 2 equals natural log of 1 plus 1 plus c. Well, natural log of 1 is 0, so that's gone. Negative 4 squared is 16 over 2 is 8. So that gives me 8 equals 1 plus c. That means that c equals 7. So I'm going to take this right here and restart, but I'm going to replace the c with a 7. That means that I have y squared over 2 equals natural log of x plus 7. So first thing I got to do is multiply both sides by 2. Get rid of that 2. Then I have y squared equals natural log of x times 2 plus 2x plus 14. Then I got to square root both sides. That's going to give me y equals square root to radical. Now this 2 we can bring up here with the x. You'll probably see that in your multiple choices on an AP test. Plus 2x plus 14. That one is done.